This program is presented by University of California Television. Like what you learn? Visit our website or follow us on Facebook and Twitter to keep up with the latest UCTV programs.
Next, on Up Next.
I think that the mismatch between any civilization we might encounter is such that it's almost egocentric to think they would care about us enough to either kill us or eat us or have anything to do with us.
Welcome to Up Next. I'm Marty Lasden, and on this edition we consider the future of space exploration with Chris Impey. Mr. Impey is a distinguished professor of astronomy at the University of Arizona. His research interests include observational cosmology, gravitational lensing, and the evolution of galaxies. He's the author of dozens of papers on these topics, and he's published 6 critically acclaimed books, the most recent of which is called Beyond Our Future in Space. Professor Impey, welcome to Up Next.
It's great to be here, Marty.
So, in a nutshell, tell me what you think are the most compelling arguments for why we should spend billions and billions and billions of dollars, I think I've got enough billions in there, to send men and women into space to explore and ultimately colonize Mars?
Well, a couple of parts to the answer. One part is that it's not going to be us spending billions and billions. There's a good part of this enterprise that's going to be self-sustaining based on, tourism, recreation, people who want to, rich people, and then maybe not so rich people who want to spend money doing it. So it's a business model at some level, whether that's orbital zero-gravity hotels or eventually joyrides to the moon and Mars. Otherwise, I think that maybe the best argument, beyond the sheer exploration of it, which I've argued is built into our genetic material, probably the best argument is that learning how to live on either of those two places, the moon and Mars, will teach us how to live more parsimoniously on the Earth, which is a problem we have. We're sort of utilizing resources at an unsustainable rate. So the moon and Mars are salutary places to try and live, because you basically have to make everything you need, the air, your water, grow your food out of, a pretty inhospitable environment. But we actually know how to do that.
Well, you were quoted in the New Yorker not too long ago as saying that given all the factors that weigh against our survival, sooner or later, to avoid going extinct as a species, we're going to have to establish settlements on other planets. And this is an argument that the late Carl Sagan made. It's an argument that Elon Musk is now making, who is not only in the business of selling electric cars, he's also building rockets. But I have to say, I do find that line of reasoning a tad creepy, because it strongly suggests to me that, whether it's global warming or nuclear war, we are doomed to really screw up the Earth. And that the only reasonable response to that eventuality is to spend the billions, if not trillions, to really screw up Mars. I mean, isn't there a certain absurdity to that?
Yeah, well, and also I agree that the sort of rank pessimism embodied by that attitude is something I don't fully subscribe to. I'm a sort of, mild optimist in the face of all the evidence is how I'd characterize it. But you're right, the act of leaving the Earth is not only is it not taken lightly, but it's extraordinarily expensive. So I don't realistically believe we are going to do more than get a little toehold in any other part of the solar system in the next 50 or 60 years. And we're never going to be able to afford to leave this planet wholesale. So basically our best bet is always going to be to, preserve the Earth. And maybe, if things go really bad, we end up living in bubble domes and little sealed environments as we would have to on the moon or Mars, but it's way cheaper to do it where we already live, especially with 7 billion people.
People talk about transforming Mars to make it more hospitable to humans. The word they use is terraforming. Right. How would we go about doing that?
Yeah, terraforming is another grandiose idea that the price tag on which I think NASA has studied it to death almost, and I think the minimum time scale and cost of terraforming Mars to be breathable air and livable with humans is, $10 trillion and 1,000 years.
We could really buy a lot of good wars with that money.
Right. So
Yeah.
I don't think terraforming Mars is going to happen. Making Mars habitable, that is, rendering Mars able to host extreme forms of life, that's actually a lower bar, and that could be done much cheaper.
So when you say extreme forms of life, you're not talking about us.
Like microbes.
Uh-huh.
So the kind of microbes that we have, microbes that can live in ice or below freezing point of water, and toxic, runoff from Superfund sites in mines in California. There are microbes that can handle almost anything, and there are microbes that are close, that we know that are close to being able to handle current Mars. And if you just warmed Mars up a little bit and thickened its atmosphere up a bit, you could green Mars, basically.
So how would we go about doing that? How would we warm Mars up?
The Elon Musk, since you've alluded to him, his version of this is we'll use all our nukes. We've got thousands of nukes.
He was on Stephen Colbert's late night show, and he thinks that the best way to do this is to nuke the planet's north and south pole.
Right.
Is bombing Mars a reasonable approach to this?
I mean, he's a very smart man, but I completely didisagree with him on that. I mean, yes, you can.
Have you let him know that?
No, you could. He doesn't return my calls. He's quite busy, but. There's a lot of power in nuclear weapons, of course, but you would render Mars toxic and uninhabitable. I mean, the long-term radioactive waste you disperse around and in the atmosphere for any humans who might want to explore or be there, you just render it a horrible, nasty place beyond the fact that it's cold and has a thin atmosphere. So that's just not a way to do it. There are ways. Okay, so I'll give you the astronomer's answer to this. Yeah. The astronomer's answer is you take a near-Earth asteroid, which needs modest deflection of its orbit to make it collide with Mars. And that's technology we can do, because we've rendezvoused with comets, and now you just have to attach rockets to a comet or an asteroid and that was already coming into the inner solar system and make it hit Mars, ideally the polar region. And you deposit enough energy in that one fell swoop, a few 100-meter sized object traveling at tens of thousands of miles an hour, bang, that gets you where you would get with 1,000 nukes.
So with all this talk about, Elon Musk says bomb Mars, you say, deflect an asteroid to hit Mars. I was surprised to learn that NASA actually has on its payroll a person with the job title Planetary Protection Officer.
Yeah.
And this person's job is to see to it that we do not contaminate the planets that we explore, particularly Mars. She says, if we're going to look for life on Mars, it would really be kind of lame to bring Earth life and find it instead.
Right.
So how does one reconcile this concern about planetary contamination with, the idea, Musk's idea or your idea to bombard Mars with something?
So the distinction, of course, was we were talking about, as scientists like to do, about the possibility of doing something. I didn't say whether I thought we should do it, and I don't think we should do it. So the fact that you could terraform Mars or start it on the road to habitability, I think is a fact. There are ways to do it. But I don't think we should. And actually most people in the astronomy or planetary science community also don't think we should globally alter a planet just for our own sake.
True or false, within the foreseeable future, intelligent machines will be able to do everything that humans can do in space, only better and certainly a lot cheaper.
True. It's almost already true. It's the robotic space probes we have. The cheaper part is beyond doubt. Sustaining humans in space is so unnatural. It's such a difficult place. Just the business to get to Mars, an 8-month journey for 2 or 4 people, the cost of tens of billions of dollars. And now we have these little cute robots that go there for less than 1% of that cost and do pretty darn well.
So doesn't all that undermine the argument for a manned space program to Mars?
There's a completely legitimate argument that it's not cost effective, or that you could spend your money better on robots. And a lot of planetary scientists who, we've been trawling the solar system with spacecraft and robots visited every planet now. They're absolutely firmly in the camp, just give us a fraction of $1 billion, we'll build a super good spacecraft, we can land on the surface of something, drill into it, whatever. So there are whole communities in the science and space area that just agree that astronauts are expensive and complicated, and have to keep them alive, and worry about them dying and so on.
Emotional issues.
Yeah. But it's always been a problem for NASA, because NASA has to engage the public. NASA has to bring the public on board, and the public, maybe they got a little attached to that.
This is very expensive public relations.
It's very expensive public relations.
Yeah. You do acknowledge in your book that there are serious health hazards associated with spending long periods of time in a zero-gravity environment. Bones get brittle, muscles atrophy, the immune system weakens, vision becomes impaired, and that doesn't even begin to include the risks associated with cosmic radiation. In fact, I just saw a piece in the, I guess it was in the Wall Street Journal, which reported on a NASA-funded study which strongly suggested that the levels of cosmic radiation that astronauts would be subjected to on a trip to Mars would cause enough brain damage to impair both memory and judgment. So doesn't that all strongly suggest that the human body is simply not built for long trips in space?
I think that's right. I mean, the Russian cosmonauts have the records for zero gravity, getting on for 5 years, a couple of them. And, but they're all still alive, and they did have health problems. So the cosmic ray and the radiation damage is clearly the biggest deal. So if you can handle the 8-month trip to Mars, and that...
Is it 8 or 9 months?
8 or 9 months, the shortest trip. And the your net dosage in that trip is way more than a lifetime's worth, but not like 10 times more. It's just like you're getting a lifetime's worth in a year. So the trick is you're going to have to, as we now know how to do, you're going to have to mine the Martian soil to make your building materials, and essentially live in these battle-hardened, shielded domes, so that in your habitat you're dealing with very little extra radiation.
Yeah, I read that for every 5 or 6 days you spend in space, you get the equivalent of roughly 1 full-body CAT scan.
Right.
So if you take 9 months with current technology to get to Mars, and another 9 months to get back, plus you have to spend 2 or 3 months on the planet itself to wait for the planets align properly for a return trip, that means, and I actually have done the math, that you get about 120 full-body CAT scans. That statistic alone would argue strongly for letting the machines do all this deep space travel.
Although to put that in perspective, whether or not we give credence to Mars One's claims that they're going to have a colony on Mars by the mid-2020s, running out of this Dutch private foundation, they still had over 100,000 people sign up for a one-way trip. So for those people, that 100 CAT scans is, so what? They were willing to sign up for a death sentence, and there were a lot of young people who did it.
Of course, the health hazards that we're talking about would be greatly reduced if we could devise a revolutionary new propulsion system that would get us out there a lot faster. Is there anything on the drawing board that you think looks particularly promising in this regard?
There are things called ion drives that operate in the vacuum of space, and they can either gather very diffuse material that's out there, just hydrogen, and turn it into a fusion source. That would be the best. Or they can just accelerate the particles and turn it into like a ramjet using the thin available material. So those technologies, all the space propulsion beyond sort of antediluvian rocket fuel that we use now, chemical energy, have been on the table for 50 years or so. None of the ideas are brand new. There's a lot of engineering involved, and there's just never been any serious development in those technologies. We put so many eggs into the big chemical rocket basket, and with the Constellation, with the next heavy lift capability for the U.S., it's going to be more of the same, just very highly engineered versions of these same technologies. The Russians are just limping along with a proton rocket that hasn't really changed its design for 60 years.
Have you heard of EM technology? This got some. This is electromagnetic technology.
Yeah.
It got some favorable reports lately. This is a form of propulsion where electrical energy is converted to thrust without the need to expel a propellant.
Right.
Do you know anything about that?
Yeah, I've read a few little technical reports that give it sort of mixed ratings in terms of, you know, really projecting it out of a lab and a very small scale to something large scale. Another technology that's been around for a while that is getting tried out, NASA's doing some experiments, and the Europeans, is the solar sail. So that's that's fairly simple. Within the solar system, works very well. It just gives you a very slow, steady impulse, and for those long trips, it's sort of a good way to go because we have these highly reflective and very lightweight, rigid materials. Material technology is helping us, so you can go way beyond, say, Mylar and have something that is 10 times lighter per unit weight, and you can now deploy a square kilometer or a few square kilometers of solar sail, and now you're talking. That's actually quite a lot of propulsion.
I've read that EM, electromagnetic propulsion, were to pan out, we could get to the moon in less than 4 hours, as opposed to the 3 days that the Apollo astronauts took. And we could get to Mars in 70 days as opposed to 9 months. So that would make a big difference, right?
And I think you're right. And so there are several technologies that are very promising. And the problem is they're all sitting at the level of R&D where they're not anywhere near ready for prime time. So I think it's a bit of a chicken and egg. So I think if you flash forward 20 years and the commercial sector, the private sector, truly has a viable model for tourism on the moon or on Mars, maybe 30 years, whatever, then there's enough revenue to fund the R&D for these activities. Because at the moment, just coming out of little labs that are sponsored by NASA, you're talking about a few $1 million a year. You're not spending enough money to develop those technologies at all.
I have to admit that I'm one of those adults that never outgrew Star Trek. And even now when the Star Trek movie comes out, I'm the first one in line. But this idea that someday we'll be able to zip around the galaxy at 5 or 6 times the speed of light. Is there anything at all in our science that I can hold on to suggest that that's even a remote possibility?
No,
nothing.
I'm a physicist.
You give me no hope at all.
Physics is a bitch. Physics is brutal.
Yeah.
And so, as a physicist originally trained, I'd say no.
Physics is a bitch. That sounds like a great title for your next book.
Yeah, that could be catchy. Could get a crossover hit with that. So yeah, relativity is telling us the energy cost of traveling through the galaxy on reasonable times is implausible.
You mentioned, though, that you see a booming space tourism industry, and I think in your book you say that that by 2035 this could easily happen. And as a part of that, you envision space-based reality TV shows, garish orbital advertising, and zero-gravity sex motels. Now, I have to admit that of all the fantasies that I have that keep me amused, zero-gravity sex is not one of them. What exactly am I missing?
Well, you're probably not missing anything. I'm just reflecting the fact that every time there's a new technology, the pornography industry or the sex industry, pretty much pushes it to its limit. There have been some times in the history of the internet when that part, the unseemly part of the internet, was 10 or 20% of the bandwidth, and so why would that be different out in space? You've got a new exotic.
Good point.
I mean, and just as a practical matter, if you want to be the first on your block to have a zero gravity baby, I mean that will be, or just conceived in space, even if they're born on the Earth. So I think, that's going to happen. And the regulatory environment is such that it probably can happen.
It just occurs to me that without gravity, there would be blood flow issues and motion sickness issues that would, let's say, weigh against having a good time.
Yeah, these can kill your good buzz, but I think people will still deal with them. And one I didn't even put in that list that I should have is sports. I mean, think of the amount of time, money, energy, and recreational endeavors are associated with sports. Once you set up your sixth gravity sporting leagues and Olympics and so on the moon, or 40% gravity on Mars, that'll be a major new thing too.
Yeah.
So we'll just mirror our terrestrial activities in these new environments, and rich people will probably happily pay for the pleasure and privilege of partaking.
You know, when I was in grade school, I was taught that there are only 9 planets in the entire universe. And those, of course, are the planets that revolve around our own sun. But then, I guess it was 1995 that the first exoplanet was discovered,
Right.
which is to say a planet that revolves around a star outside of our own solar system. And since then, I guess it's something like 2,000 exoplanets? 5,000 now.
They're not
okay.
all confirmed, but with high
Okay.
probability, 5,000.
But you know what I find even more amazing and actually truly wild is that based on what we've seen so far, they're estimating that there are something like 11 billion Earth-like planets in our galaxy revolving around sun-like stars
Right.
at distances that at least theoretically make it possible for there to be life on these planets. So what all of that tells me is that we're not alone, that there has to be life out there, and that some of that life is bound to be intelligent and bound to have advanced technology. Is that the way you see it?
That is the way I see it. But you're like me. You're sort of thinking of the numbers and inferring, you know, a likelihood based on these overwhelming numbers. I talk to biologists who are not as sanguine. Biologists take a different view of this, and it's really based on their judgment, given that we don't know how exactly it happened, of the likelihood of life forming on one of these habitable worlds. So biologists, as a profession, I haven't done a fair sample, but most of the ones I speak to are far less optimistic that these habitable planets have anything on them. They think it was a very unlikely event that caused life on Earth. I don't agree, but I'm not a biologist. I'm with you that if you got 11 billion petri dishes and a lot of time, billions of years before the Earth even formed, then the odds of nothing happening on any of them, I think, are very small. The odds of, but also we can then look at the Earth and say, well, for most 90% of the age of the Earth, life was microbial and invisible without a microscope. So maybe having plants and animals and people and primates and so on is an unlikely eventuality. You got hundreds of billions of species and a few billion years and nothing really happened, so maybe that's the weird thing. So then there's a lot of microbes out there in space, but not a lot of advanced life.
You are a big science fiction fan.
Yeah, absolutely.
So when it comes to human-alien contact, what's your favorite story?
Oh, that's a good question. I don't know if I have a single favorite, because I mean I tend to read more hard science fiction where sort of we're doing more the Asimov style, or the style where it's humans out there just, you know, evolving and spinning off our technologies into different regimes. I was taken by a story classic now called The Berserkers. I can't remember the author.
Yeah.
And it's this kind of provocative idea of a superior race that are out there just sort of watching pesky species like ours that get technology and are about to leave their planet, and they sort of essentially wait till you're just ready to leave home, and then they obliterate them just to keep the galaxy clean and safe from these pests.
And
so
we're the pests.
Yeah, and the berserkers are the guardians of the galaxy, just because they've seen how unruly we are. We almost kill ourselves with nuclear weapons, and now we're about to leave the planet. Okay, enough of them. So the berserkers are sitting there, and of course in the story, as you read it, you realize, oh wow, we're just about to get on their radar, and we don't want to be on their radar.
Actually, you know, my favorite story is a Twilight Zone episode called "To Serve Man," which these technologically advanced aliens come down to Earth and promise to rid us of the scourge of war and poverty and hunger. But the twist is that just when we're embracing these aliens with open arms, we discover that this book that they're carrying around with them, which is entitled "To Serve Man," is a cookbook.
Right.
Yeah.
Yeah.
Yeah. So do you think we have to worry about technologically advanced aliens coming here with a hankering for human flesh?
I think that the mismatch between any civilization we might encounter is such that it's it's almost egocentric to think they would care about us enough to either kill us or eat us or have anything to do with us, you know.
Unless they find us particularly tasty.
Well, that's right, but that's, you know,
Yeah.
I think we're kind of gnarly and tough as a species.
Do you know? I mean, that's the thing. I mean, I guess we'd have to ask cannibals to.
Yeah. No, I think I've read that human flesh is not.
no big deal.
It's not terrible.
Yeah. Well, it's all in the sauce.
Right. Yeah.
The science fiction writer Arthur C. Clarke, he once made the point that there are only two possibilities: either we're alone in the universe or we're not. But then he said both possibilities are equally terrifying. Do you think that's true, or do you think there's one that's more terrifying than the other?
I actually would be I'm more terrified personally by being the alone aspect, because as a scientist, because of the statistics we were talking about, it tells me we're kind of a fluke.
Yeah.
That what happened on this planet is a fluke. And it's not like I need teleology and I need some purposefulness built into the science that I do. But it's kind of scary. I mean, it's another layer of existential angst, if you like. You can go beyond your own demise and the fact that you'll stop existing, to the fact that humans will stop existing, to the fact that in this ancient, huge universe with so much potential real estate, we were the only experiment that got self-aware and figured out the universe. That's another layer of existential awareness that's a little uncomfortable.
Yeah. So as a final question, I want to ask you the ultimate final question, and that is, how do you think our universe will end? And when it does end, what's our backup plan?
Backup plan, yeah, it's good to have a backup plan. So if we believe the accelerating expansion of dark energy, even if we don't know what dark energy is, we think it's going to accelerate in the expansion. So the astrophysics of that is pretty clear now, that in a few billion years, before the sun dies, so not that long, we'll merge with Andromeda, the next nearest big galaxy, the Milky Way, to the Milky Way. So we'll be a big galaxy. And in only a few billion years after that, all the other galaxies will be ripped from view because they'll be moving away from us faster than light. So the universe will become this sort of lonely universe of our one now merged galaxy. The stars will all die, and that's a one-way arrow of time, because as stars get old and die, the thing that made our star form, billions of years after the galaxy formed, will stop being possible, because all the gas is going to be mopped up in stars and dead stars, white black holes, neutron stars, white dwarfs. So star formation will cease, and the galaxy will grow dark. So we'll be living in a small universe, everything else having fled by the accelerating expansion of stellar husks. However, that's not a pessimistic scenario.
That's not pessimistic.
It sounds bleak, but
yeah.
It's not, because we shouldn't be unduly attached to having, a light in the sky, a star. There's going to be a ton of gravitational energy in this system forever, almost forever. Black holes may evaporate if Stephen Hawking's right, but that takes 10 to the 80 years, a crazy amount of time. So once we get over the emotional attachment to a star or that kind of a light bulb, if life continues to exist in this galaxy, us or other species, it can just keep going happily along in this bizarre new universe, this small pocket-sized dark universe, because there's tons of gravitational energy to do all the things you want to do.
So under that scenario, are there any stocks that I should think of buying?
If there was a gravity stock, if Einstein had, really put a patent, he was working in a patent office. Do you think he would have patented gravity?
You would
and
think.
Built some devices and started a company, and then that would be the stock I'd recommend.
Okay, very
but
good.
At the moment, unfortunately, there's no good gravity stock.
Okay, well, we'll keep a lookout for that stock. Professor Impey, thanks so much. I really appreciate it.
I enjoyed it. Thank you, Marty.